It's a problem solving technique, right? So what does it mean? Basically, it is used to solve problems, but solve problems in a very, what do you say? In a very specific manner. What does that mean? Like, let's say, what backtracking does is it tells us that suppose you have multiple options. Okay, suppose you have multiple options. So you will keep searching or keep trying for different options. You will keep trying for different options till the point, keep trying for different options till you get the answer. Get the answer. Okay. Example. So, guys, for the last few days, I've been having a terrible, what do you say, throat ache. Not been having a very good time. So, my parents told me that, you should get, like, let's say, some medicine. Okay. Like VIKS or something like that, some medicine. Okay. They asked me that go outside and don't come back till the point you don't get a medicine. Okay. So, suppose this is my house. This is my house. Okay. Now from my house, there are 4 different routes that go. One of the routes goes in north direction. And after that, there are 2 more options here. Sorry. One of them goes here. Another one of them goes here. Then it goes here. And it goes here. Another option is it goes here. Then from here it goes here. And then from here it goes here. Here. Different routes. Another one is I can go here, and from here it goes here. And from here, there are 2 options. This one, this one, this one, and this one. And another one is this one, just one option. Now, the red parts basically represent the medical shops. The red parts or the red lines, basically, these represent the different medical shops. Okay. Okay. Now, currently, I am standing at this position. Okay. Now I need a medicine. I need a medicine no matter what. I need a medicine no matter what. Okay. I need a medicine no matter what. So what will I do is, at this position, I have 4 options. I can go here. I can go here. I can go here. I can go here. Correct? I have 4 options. Yes or no? I have 4 options. Correct? So let's say I choose this option. I choose this option and I go. I go. I keep going. And I reach this particular point. But here, when I reach, I realize that I have 3 more further options. Correct? I have 3 more further options. Yes or no? So let's say I say that, okay, I'll go for this particular shop. But this shop is closed due to closed, let's say, due to New Year. This shop is New Year ke karan closed. That means I did not get the medicine. Correct? That means I did not get the medicine. So what will I have to do? I will have to return, but I won't return immediately back. I won't return to my house. I would return to the last point where I took a decision. This was the last point where I took a decision. So I'll say, okay, at this point, there were 3 options. I went with the previous one, or I went with this one, which did not result in an answer. So let me go and try the next option. Correct? Isn't that exactly what you will do? Isn't that exactly what you will do? Of course you will do. But for that, you should remember that at this point, there were 3 options and you took this one. You should remember ki kaun sa path liya tha. You should remember which option you took, which did not result in an answer. So you will take the other option after this, which is this one. Which is this one. Correct? Which is this one. Yes or no? Yes or no, people? But again, you go here and this shop is also closed due to New Year. This shop is also closed due to New Year. Correct? Correct. So what do you do in that case? In that case, you return back to the original point and try the next option, the third option. That this is also another shop. But again, this is also closed due to New Year. Now you return. When you return back at this point, what do you feel? That okay, there were 3 options, none of them worked. So what will you do? You will go back to your house and try the next option from there. Because dawai to chahiye bhai. Right? You will go back even further. You will go back even further and try to go this way. That okay, I took a decision here. Let me just start from here again. Okay, at this point again, now you have 2 options. So you said, okay, I'll go here. But again, this also is closed due to New Year. So what happens? You go back to the previous point where you made a decision that, okay, I made a point here. And then I'll go to the next option, which is this one. But this shop is also closed due to New Year. So what happened? You come back and then you go back even further. That, okay, let me just go back. And then you go this particular shop. But this shop is also closed due to New Year. So what do? You have no option but to return. And then you go for the next option, which is pending. There is only one option which is pending now. So you go there. You go there. At this point, you have 2 options. So what do? Let's say you go here. But this shop is also closed due to New Year. Now what do? What do? You go back to the previous point where you made a decision. You made a decision at this point and then try this one. Finally, this shop is open. You get your medicine and then you come back. How many of you got this? How many of you got the story? How many of you got the story? Got the story? But there are a couple of things. There are a couple of things here. In this case, doesn't it feel like brute force? Doesn't it feel like brute force where I explored every possible option to get the answer, which is correct, right? Every possible option to get the answer, correct? Doesn't it feel like brute force? Of course, it is brute force only. Correct? Of course, it is brute force only. Right? Yes or no? Yes or no? Right. But there was another thing. Right? There was another thing. What was that thing? The thing was, at some point, I had to remember the points where I was making the decisions. Right? Like basically, I had to remember that here, there was the 3rd option and I have to take this option. So let's say if this option didn't work out, I'll come back here and try the next option, right? So there were certain points that I needed to remember, correct? Yes or no? Certain endpoints or certain decision-making points which I needed to remember, correct? Certain points, certain segments which I needed to remember, correct? So this is brute force, but this also requires remembering some of the decisions that we made, right? So basically some states have to be remembered. Just like a function has a state, I can remember some of the function state so that I can come back to it. Is it making sense? Can I say it like this? Remembering the states so that you can come back to it. Whatever is the situation at this point, you remember it so that if this didn't work out, you can come back to it. Yes or no? That is something that recursion does by default, correct? That is something that recursion does by default, correct? What does recursion does? It stores the states, right? Because of the recursion stack, the states are stored, right? The states are stored, right? So let's say if you ever want to apply brute force such that you want to explore all possible options, if you ever want to apply brute force such that you want to explore all possible options, but also you have to remember some of the states. You have to remember the states also of the function so that you can come back to that particular state. You have to remember the state also. So you can apply or you can use recursion for that. Yes or no? You can apply recursion for that. This combined together is called as backtracking. That's why if you remember some days back, I said that this is backtracking and this is recursion. Every recursion problem, every backtracking problem is a recursion problem, but the reverse of it is not true. Why? Because backtracking is a problem solving technique in which you explore all possible options to get the answer. But how do you explore all possible options? With the help of recursion. And why does it happen? Because certain states have to be remembered so that you can come back to it. In fact, it will be very hard for you to sometimes figure out whether it is recursion or it is backtracking. Because backtracking is a technique which uses recursion, correct? right? It's having a lot of time complexity. Of course, it has a lot of time complexity. We'll speak about time complexity also. But before that, I wanted to touch upon this. How many of you got this? Again, it might not be 100% clear, but does it make sense? Okay, cool. Let's try to understand. Okay. Yesterday, we were discussing one problem called as subsequences. Remember, find the weird sum, or a couple of days back, basically, we were discussing one problem called as subsequences, right? Generating all subsequences and everything. Remember? Remember, today is a day of connecting dots. We'll connect a lot of dots. And I told you that for every problem, what are the options that you have? You can either select it or not select it, correct? Correct. So, let's say you are given this problem, that you are given this ABC. This is a string. You have to generate all subsequences for it. Okay. So initially, this is how your subsequence will be looking, correct? Completely empty, nothing to be done. Correct? Completely empty, nothing to be done. Yes or no? Completely empty, nothing to be done. So after that, what happens? You come across the first character. Now for the first character, what are the options that you have? You can either select it or not select it. Correct? You can either select it or not select it. We spoke about order being very important. Remember, right? We spoke about order being very important. Remember, people. We spoke about order being very important. That first A has to be done. Only after that you can go for B. And once it is done, you cannot come back to A. So whatever decisions, either you have to select A or not select A, that has to be made right now. Correct? So there are two options for it. I can either select it or I can ignore it. So let's say if I decide to select it, this is how my subsequences will be looking. Correct? This is how my subsequence will be looking. And then I will arrive at B. And for B, again, I will have two options. I can either select it or I can ignore it. Correct? I can select it. I can ignore it. Yes or no? For this also, I'll have the same two options. I can either select it or ignore it. Let's say if I select it, what happens? This becomes AB. Okay. And then I arrive at C. For C also, I'll have the same two options. Same two options. Either I can select it or I can ignore it. So let's say if I decide to select it, what happens? A, B, C. Is this one of the subsequences of this string? Is this one of the subsequences of this string? Yes, 100%. But what would have happened? What would have happened if I decide to not select C? For that, I will have to go back to the previous state and try the next option. Correct? I will have to go back to the previous state. That is backtrack to the previous step and try the next option, which is what would have happened if I would have not selected B? C. This would have looked like this. This is also one of the subsequences. Yes or no? Yes or no? So I go back. But all this was possible when you decide to select A and you decide to select B. What would have happened if you would have decided that I won't select B at all? So what will you do? You will backtrack to the previous state. Okay, you will backtrack to the previous state and try the next option. Backtrack means all the decisions that you have done, they will be undone. That is, to get to this position, what you had to do? You had to select B. But if you're going back from this particular position, you will have to deselect B. Yes or no? Ulta karna padega na to get to the previous state. So what happens in this case? It was A, B. Now it will just be A. Why? Because you have taken the decision that I won't select B. Correct? So basically you went like, okay, I will select this. I will select this. And then for this, you tried two options, either selected or not selected. But then you went back. Then you went back, look at this undo option. To this point where you had just made a call on A that I'm not going to select B. So directly you move to C. So when, again, the call on C has to be done again. For C, again, you will have the same two options that, okay, you can either select it or you can ignore it. So if you select it, what happens? Comes AC. This is also one of the subsequences, yes or no? This is also one of the subsequences, yes or no? Folks, don't think about code. Guys, the worst mistake that you can do right now is how will I implement this? Don't think about it. Please don't think about it. Right now, just try to make sense of this. Whatever the structure is being formed, just try to make sense of this. Right? Whether it will be AC, right? That's one of the subsequences. Why A from branch A? Did not get this. One second, Naveen, let me. Okay, sorry guys. Is there some background noise coming up from my end? Then it's great. Yes, Naveen, can you hear me?
Am I audible, sir?
Yes, Naveen, you're audible. Please tell me
Yes,
the.
sir. Yes, sir. So I'm saying like we are creating branch from A to itself A. There are two A. Adjacent to AB, there is a A.
You're talking
Yes,
about
yellow. From yellow line, sir.
yellow. Okay. So
Yes.
see.
Two
First,
A are there.
initially, this is a subsequence that is given to you, right?
Yes.
Just give me 1 second. Sorry. Just give me 1 second. Sorry. Guys, give me one
You are
second.
not.
Just,
Yes.
just
Okay.
1 second, please. Sorry, guys. Just 1 second. Extremely sorry.
Yes.
Something.
Sure, sir. Take your time.
Cool. Sorry, guys. Something came up on clarity.
No problem, sir.
Yeah. Okay. Let me go back. So, where were we? What happened here is, okay. Where were we? We were at A, right? Initially, you remember that for A, I had two options, correct? That I could either
Yes.
select or I could ignore it. Okay. So I went with
Yes.
this that I will select A. If I select A,
Yes.
now my subsequence is looking like, correct?
Hmm. Hmm.
I have to
A.
make decisions one by one. That first, make the decision for this. You want this or you don't want this. But once it
Yes.
is done, you will come to the next element. And for the next element also, you will have the same two options. Either you can select B
Yes.
or you can ignore B.
Okay.
Right. So those two arrows
Yes.
basically means that for B
Hmm.
also. So let's say if you go with this one, it looks like this. And if you go with this one, it just looks like this. Correct?
Yes. Yes.
Getting my point? That's the idea.
Yes. Got it, sir. Thank
Guys,
you.
how many if you get this? How many if you get this
Yes.
part? How many if you get this? Okay, great. Naveen, all okay till this point, man?
Yes.
Okay.
Okay.
Great. Now let's move on. What happens next is full screen. Is it not full screen? 1 second, let me check. Okay. Also subsequence. Yes, of course. All substrings are subsequences, but the reverse is not true. Okay. Yes, of course. That's what subsequences mean. No, Saksham. That's what subsequences mean, right? Okay. So once I'm done with A and once I've done with B, I have to make a call on C, but I can only make a decision on C once I have made a decision on A and B. I cannot say that first I'll make a decision on A, then I'll make a decision on C, and then I'll make a decision on B. No, it doesn't work like that. First, I made a decision on A, that I'm selecting it. Then I made a decision on B, then I'm selecting it. Then I made a decision on C, then I'm selecting it or not selecting it. And then I tried the next option, that what would have happened that if I selected A, but I did not select B, and then I selected C. So it becomes AC. And then what happens if I select A, if I don't select B, and if I don't select C? What happens? It just remains A. Correct? Exactly, Arun. Correct. So guys, do you realize how did we get to these different points? That's the most important point. See here, there are 4 options. How did we get to these 4 options? First options, let's talk about select A, select B, select C. So what do we get? A, B, C. Then we go with select A, select B, don't select C. Don't select C. So what do we get? A, B. Correct? This is one subsequence. This is another subsequence. Then we go with select A, don't select B, and select C. Then what do we get? AC. And then finally we say select A, don't select B, and don't select C. So what do we get? Just A. These are all the subsequence. These are all the different permutations that we can make, correct? These are all the different permutations on this. In this way, one thing is common. Select A was common, right? Select A was common. We did not explore the option when we are not selecting it. How many of you got it? How did we get to these different permutations or subsequences? Permutations means just different arrangements, correct? How many of you get this? But what would have happened if you would have not selected A in the first place? For that, I will have to go back from here to here, and I will have to go back here and try the next option where I don't select A. If I don't select A, then what happens? My subsequences looks like this. I have decided that I won't select A. Then what do I have to take a call on? I'll have to take a call on B. And for B, I will have 2 options. Either I can select B or I can ignore B. Correct? Either I can select B or I can ignore B. Yes or no? So let's say if I select B, what happens? B. So I've made a decision on this. I've made a decision on this. Now time to make a decision on C. For C, what are the options that I have? What are the options that I have? Either you can select it or you can ignore it. So let's say if I select it, it becomes B, C. How did we get to this particular point? Reject A, select B, select C. Correct? That's one of the ways to do it. But now let's go back and try the next option. What is the next option? Select A. Oh, sorry. Reject A, select B, and reject C. So this comes out. Correct? So I go back. At this point, I've tried both the options. So what do? I go back even further and try the next option. What is the next option? Reject A and reject B as well. So this remains empty. Reject this and reject this. Now time to reject. Or time to take a call on C. Not reject, but take a call on C. For C, what are the options that we have? We can either select it. So it becomes C. How did we get to this particular point? Reject A, reject B, select C. And then finally, one more option. Reject A, reject B, reject C. So finally, what do we get? This one. Yes or no? How many of you get this? How many of you get this? Now, finally, if you look at it, just look at the bottom half. Just forget about the order and everything. Don't you think all these are the different subsequences of this array? Don't you think all these are the different subsequences of these array? Yes or no? Yes or no? Yes or no, people? 100%? Yes or no? Yes or no? Okay. Not subarray. Don't say subarray. Subarray is a different thing altogether. Substring is not equivalent to subsequence. If you say this, right? Very important. Okay. But now still it might not make sense how this is related to backtracking, correct? It still might not make sense how it is related to backtracking, correct? Is subsequence equals to subarray? Rajesh, I have explained this 4 times. The last time I'm explaining this now. This is a subsequence. This is a subarray. Why don't you know the difference between subsequence and subarray? Were you not present in the last session? Guys, we discussed substrings and subsequences, right? We discussed this, no, folks? This was one of the things that was discussed in unit 1. Guys, कैसे चलेगा ऐसे? वापस भेज दें? Should we send you guys back? Of course, it is a subsequence, right? Empty one is also a subsequence, right? Where you decide to not select anything. Correct? Empty one is also a subsequence, no? Where you decide not to select anything. Correct? But still, if I tell you this is backtracking, you will still won't be able to get it. You still won't be able to get it. Yes or no? If I tell you that this is backtracking, you're making different options, you're coming back to the previous state, nothing of it like makes sense. So that's why let's take another example. How many of you have ever been to the mall? Any mall, D-Mart, ye, wo, kuch bhi. How many of you have ever been to the mall? How many of you? Phoenix, Bangalore, okay. Okay. So generally, in some cases, in malls, there is a lot of, like on some days, there is a lot of traffic in malls, correct? There's a lot of traffic in malls, correct? Correct? Correct, yes or no? Correct? Yes or no? Sorry, guys, my voice is just tingling a bit. Okay. So generally, let's say if there is a mall in which there is a lot of traffic, or, generally in malls, there are racks, right? There are racks kept like this, right? Something like racks are there. Like, let's say if there is a mall of characters, okay? If there is a mall of characters, okay? And there are 3 types of characters that are kept. Okay. The first one is of, let's say, type A. Second one is of type B. Second one is of type C. Now this is you. Okay. When you go shopping, you take that shopping cart with you. Remember, you take that shopping cart with you, right? So let's say this is your shopping cart. Okay. Let me just draw it. This is your shopping cart. Okay. Now, the way the mall has been, the mall has basically made a like basically said that you can go in this direction only. You cannot say turn mark any. One way hota hai na, jaise, it's just a one way. You can either go forward or reverse, but same. You can't go aisa ulta karke, just one way. You basically can travel in one line. You can come back. Like, let's say you can come back, but you'll have to take a reverse gear. Jaise car ka hota hai na, reverse gear. You go straight, you come back. Something like that. Let's imagine that. Although it hardly matters in this case. Okay. Now, suppose you start shopping. You start shopping and you come across this. Now, what are the options that you have at this point? What are the options that you have? You can either buy A or you don't buy A, correct? You either buy A or you don't buy A. That's the only 2 options you have, correct? You either buy A or you don't buy A. That's the only 2 options, right? Ki aur koi option hai? That's the only 2 options, or is there another option, people? That's the only 2 options, right? So let's say if you buy A, that means you will put it in your shopping cart, or you won't put in your shopping cart. So let's say at this point, I say that, okay, here I will have 2 options. when I'm passing through this, I will have two options. Either when I reach B, I would have either bought A, I would have not bought A. If I would have bought A, that means when I reach B, my basket would look like this. Otherwise, my basket would look like this, correct? These are the two options. Yes or no? These are the two options. Yes or no? Correct. Now, after this, when I come across B, for B also, how many options do I have? For B also, how many options do I have? Two options. I can either buy it or I can not buy it. But if I've already bought A, then that means when I arrive at C, I will have my basket can look like this. A, B. My basket will look like this. A, B, or just plain A, correct? Because I made the assumption that I had already bought A. But what if I had not bought A? In that case, when I arrive at C, what are the options that what are the options that I will have? The options that I will have is either B or nothing. Correct? Correct? How many of you are able to understand? I start shopping. I make a call for A, then I go to B. But based on whatever call I make for B, I have two options for when I reach A. But when I'm done with that, I will have four options on it. And similarly, now when I arrive at C, if I've already bought this, how many options will I have? My basket could look like this, A, B, C. Or it can look like A, B. But if I had not bought B, then it can look like A, C, or just A. But all this was possible when I bought A. If I had not bought A, then it would look like B, C, or just B. Or if I not even bought A and not bought B, then it would have looked like B, just C or empty, nothing. Correct? Yes or no? These are the options, no? These are the options, no, folks? Yes or no? How many of you understand this bit? How many of you understand this bit? Now think in terms of backtracking. Now think in terms of backtracking. In backtracking, what do? You make a call, you make a decision, go ahead with it, go ahead with it, go ahead with it, go ahead with it, and then come back. So let's say here, I made a decision that I'll buy A. Okay. I made a decision that I'll buy B, and then I made a decision that I'll buy C. But let's say if I want to come back and try to give back C, then I'll get A, B. That means I need to remember this particular function, correct? I need to come back to this particular function. For that, I have to come back to this previous state. And this is what backtracking does. And this is where backtracking needs recursion. This is where backtracking needs recursion. How many of you are able to understand this, and how many of you feel you are, I would say, close to the code? Even if you're feeling 10% of it, you're not close to the code. You're definitely not close to the code. Okay. But okay, come on, take a couple of minutes, go through this. Let me know if you have any doubts. Take a couple of minutes, go through it. Let me know if you have any doubts. Come on. Go for it, guys. Come on. Guys, try to make sense of the fact that how you are basically going back to the previous state. It might not make 100% sense, but give it a shot. It will. Give it a shot. Can we use previous like linked list? You can probably. Will we be using if else statements? I don't know. How it will remember that basket has AB? It won't. The stack would. When you go back to the previous function, that's where the stack would remember, no? That what was the state of the function when you came back to it. Hanumat, it won't remember that. Okay. 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 So how many of you understood this? Yes, that's fine, Abhishek, 100%. Again, guys, you still see one thing that you will always find it hard to understand, that what is the difference between recursion and backtracking. And in fact, let me just go and say this on record, that backtracking is just a fancy way to say recursion. It's just a fancy name for recursion. Just a fancy name for recursion. More or less, it does the same thing. But generally, backtracking is a problem-solving technique. Or, very simple way, recursion plus brute force is backtracking. Okay. So backtracking is a problem-solving technique which uses recursion. It's just another fancy way to say recursion. But how will we code this out? Okay, how many lines of code do you think will require for this? Because I have to do this completely. How many lines of code will be required? Come on. You can say that. Let's try to understand. Let me just share my screen. Let me just open this up. Okay. And here, let's take a string. Let's call this ABCD. Okay. And let's call this function generate subsequences in string. And the new string will be basically the new subsequence that we are trying to generate. Okay. Now, if I just want to print the non-empty one, so I'll say if new string dot length is not equals to 0. So join. I'll take a new array, but basically just for this, that's much easier to handle. Otherwise, what will I do is if I'll probably need the index as well. So let's take that here. And if that index is equals to str.length, that means there's nothing to be done. So simply return. Otherwise, for all the characters starting from this, you have two options. Either you can include it or exclude it. So let's say if I decide to include it, what happens? I will push it into my new string, and then I'll move from here to the next one. So generate subsequences, str, and then I+1. Otherwise, I'll move. And then finally, all I need to do is generate. Sorry. Guys, it might feel very shocking, okay? You still might feel that nothing is making sense, and that's okay. Don't worry about it. Let's try to print it. Let's see what it does. Let me just make it even more easier for you guys to understand. Is it all the subsequences? Is it all the subsequences? Is it all the subsequences? But how does this work? How did these 10 lines did that? That's the most interesting part, right? That's the most interesting part, no? Yes or no? Yes or no? That's the interesting bit, no? Yes or no, people? Yes or no? So now this is where what we'll do? What we'll do in this situation? When nothing makes sense, what do we do? I'm not going to do it for, let's say, a bigger string. Let me try for a smaller string first of all, because it takes too much time. Yes. what we'll do is a dry run. Perfect. So let me just okay. This is the code. And yeah, but before I start doing a dry run, do you guys want to go through it? Do you guys want to go through it? Come on, take a piece of paper and start doing it. Come on. Come on, take a piece of paper and start doing it. Yeah, take a couple of minutes. That's okay. I'll just get some water. Come on. Yeah. So anyone solved? Anyone got this? Anyone got the hunch? Anyone got the hunch? How is it working? Anyone got the hunch? Okay, come on. Let me do it. Shall we start? People? Shall we start? Almost. Okay. Well, almost. I don't trust almost, but chalo koi nahi. So let's go the same approach. This is my recursion stack. Initially empty. Okay. And here, okay, I start with my string. What is my string? ABC. New string, currently empty. Now this is very important. Okay, this is my new string. Right now it is empty. It's a global variable. Okay, guys, do pay a lot of attention now. Everyone with me, do pay a lot of attention at this point. Okay, now at this point of time, a function is called. Let's call this function f1. Okay, what happens to this function? This goes into the recursion stack. Now string is not going to change. ABC, new string is a global variable which is written here. The only thing that you need to keep a track of is index. What is the value of index for f1? 0. Correct? What is the value of f1 index for f1? 0. Guys, if you miss me at any point, it might not make sense. So you need to be with me at all points. Okay. You need to be with me at all points. Otherwise, there's a decent chance that you might miss me. Okay. So stay with me at all points. Stay with me. Stay with me. Super focused. Exactly. Now, as soon as this function is called, we start going inside this. Now tell me, is new string dot length not equals to 0? Is that correct? What is the length of new string right now? No, it's not true. Is index that is equals to 0 is equals to str dot length, which is 3? Definitely not. So we come across this one. Now the way while loop or the way for loop works is, this is the initialization condition. I is equal to index means what is the value of I? I is equal to index means what is the value of I? 0. So the value of I is 0. Is 0 lesser than str dot length, that is 3? Is 0 lesser than str dot length, that is 3? Correct. Now the way I understand for loop is, I plus plus won't happen till the point these three lines happen. Am I correct? I plus plus won't happen till the point these three lines are done. Yes or no? Am I correct? Yes, 100%. So what do I do? The first line happens. What is the first line? New str dot push. What will I push? str of I. What is str of I? Very important. What is str of I? A. Okay. Now what is this next line? This next line is a function call. Okay. The next line is a function call. What is this function called? F2. F2. And then str, same, new str in front of you, I plus 1. I plus 1. What is I plus 1 for this? I is 0. 0 plus 1 means 1. So now what has happened is, initially we had an empty subsequence. We decided to select A. So now we have this A. Am I correct here? Am I correct here, folks? Am I correct? Everyone with me? I'm going to go very slow, so just stay with me. But now tell me one thing. Can I move to this next line, new str.pop, or will I have to wait for it to finish? Wait for F2 to finish, right? F2 is a function call. Till the point F2 is not done, I cannot move to new str.pop. Remember this point, right? Very important. Remember this point, okay? So now I'm back at F2. What happens at F2? Is new string dot length not equals to 0? That's true now. What is the length of the new string? What is the length of the new string? 1. Is it not equals to 0? Definitely. So what do? Console.log new string. What do I get? A. Okay. Now I move to the next line. What is the next line? Is index equals to str.length? Index for F2 is 1. Is it equals to str.length? No. That means I can start the loop. Now F2 also has started its own loop. But what will be the value of I now? I is equal to index means what is the value of index for F2? 1. So I will start from 1. Is 1 lesser than 3? That is str.length. Yes. So what happens inside this? New str.push str of I. What is str of I now? What is str of I? B. That means another function call. We have decided to select B. What will happen after this? New str.push str of I. Another function call. What is this function call? F3. And what will be I plus 1? Because string is this. String is the same. New str is in front of you. What is I plus 1? I is 1. And 1 plus 1 means 2. Can I move to the next line? New str.pop? No. F1, then F2, then F3. So F1 is waiting for F2. F2 is waiting for F3. Am I correct on this, folks? Am I correct on this? Great. Now, so let's start doing F3. For F3, is new string dot length not equals to 0? That's correct. New string dot length is AB. Is AB not equals to 0? Is AB not equals to 0? Yes. So what happens? I'm going to print it. Okay. Now what is the value of index? What is the value of index? It's equals to 2. Is it equals to str dot length, which is 3? Is 2 equals to 3? Okay, great. That's not true. So I start with the loop. But what will be the initial value of I now? I is equal to index means for F3, I will start from 2. Is 2 lesser than 3? Is 2 lesser than 3? Yes. So what happens? New str dot push str of I. What is str of I now? What is str of I? C. That means you push C. That means you decided to select C also. How did you get here? You decided to select A, then you decide to select B, then you decide to select C. Correct? So this line is done. What is the next line? F4, another function call. F3 is also making a function call. But what will be the value of I plus 1 now? String is there, new string is there. What will be the value of I plus 1? 2 plus 1, which is 3, Now what happens at this point? Is new string dot length not equals to 0? Is new string dot length not equals to 0? Is it correct? It is definitely not equals to 0. So what is it, new string? A, B, C, correct? And then what happens? Is index equals to str dot length? What is the value of index for F4? 3. Is it equals to str dot length? Yes. So it returns. F4 returns. Return means F4 will go back to F3. Perfect. And when you arrive at F3, tell me one thing. The second line of the loop is done. Now finally is the time to move to the next line, right? What does this next line do? New str.pop. What is new str.pop? What does pop does? What does pop does? It removes the last character of your array. What is the last character of your array right now? C. If I remove this, what does new str become? AB. Doesn't that mean that I'm going back to the previous case or previous state? Doesn't it mean like I'm backtracking back to the previous state? So basically this line is the backtracking line. How many of you realize this? That, okay, I made a call that I'm going from A to AB, AB to ABC, but I want to go back to AB. Correct? So what happens here? New str.pop. That's the backtracking step. How many of you were able to realize this? How many of you were able to realize this? Even if you didn't, you will get lots of opportunities now. Okay. How many of you get this? How many of you get this? Stay with me, stay with me, stay with me. I came back from F4 at F3. What did I do? At F3, what did I do? I reduced the last line. Okay, I basically got the last line done. New str.pop. And after this, what will happen? I plus plus. So for F3, I plus plus means I will become 3. Yes or no? Because 3 lines are done. So I plus plus is done. Right? Now, is 3 lesser than 3? Is 3 lesser than 3? No. If that's not the case, that means F3 is done. This for loop is done. And because there is nothing below it, that means F3 is done, correct? And since F3 is done, where will it go back to? Where will the control go back to? F2. Exactly. Exactly. The control will go back to F2. And at F2, what will happen? New str.pop. New str.pop means what will happen? You will remove the last character of your array. What is the last character of your array? P. That means where did you go? To this point? Yes or no? Yes or no? Yes or no? So you're going further back. How many of you realize this? How awesome is this now? Right? But again, it's still not done. This line is done. After this, what will happen? I plus plus. The current value of I is 1. 1 plus 1 means 2. Is 2 lesser than 3? Please confirm. Is 2 lesser than 3? Please confirm. Yes. So what happens? I go inside. New str.push str of I. What is str of I now? What is str of I now? Str of I. What is str of I? The value of I is 2. So what is str of 2? C. So you push C. And what is this next line? This next line is a function call. Again, a function call has been called F3, but this time, what will be I plus 1? Can you please confirm? What will be I plus 1? 3. That means you went in this direction where you ignored A and then you went with C. Correct? You ignored B and then you went with C. Correct? So at F3, is new string dot length not equals to 0 for F3? Is new string dot length not equals to 0? Correct. So what do you console? AC. You console AC. And then what happens is index, that is 3, equals to str dot length. Is that true? Yes. So you return. So F3 returns means where does it go? Where does it go? F2. And at F2, what happens? Once you come back, what is the line that will be executed? New str.pop. What is the value that you will be popping out now? C. And if C is popped out, that means we are back to this particular situation, correct? And once we are back to this particular situation, I plus plus will happen. I is equals to 3. Is 3 lesser than 3? Is 3 lesser than 3? No, definitely not. That means F2 is done because for loop is done, nothing below for loop. So F2 is done. And since F2 is done, can I remove it from the recursion stack so that the control will go back to F1, and at F1, what will happen? New str dot pop. What is the value that will be popped out now? What is the last element of your array right now? So you pop it out, and where does it go? To the top. Correct? 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 And then what happens? I plus plus. I plus plus means 1. Is 1 lesser than 3? Is 1 lesser than 3? Yes. So what do? New str dot push str of I. What is str of I now? What will you push? What is str of I? It's B, 100%. So you push B, and what is the next line? A function call. Yes. That means you came here after ignoring, and then you are selecting B. Okay. You came here, you selected B, and what will be the value of index for F2? I plus 1. I is 1. 1 plus 1 means 2. Perfect. 2. So now we come back to this situation again. Is new string dot length not equals to 0? Please check. Is new string dot length not equals to 0? Of course not. It is 1. So it is definitely not equals to 0. So what will you print? New string, which is B. And then is index that is equals to 2. Is it equals to str dot length? Is it equals to str dot length? No. So what happens in that case? The for loop begins, and what will be the initial value? I is equals to 2. Correct? Because I equals to index, right? 2, no? Check this out. Correct? Is 2 lesser than 3? Definitely yes. So what will happen? New str dot push str of I. That means what will I push? See, perfect. Okay, and then what is this next line? A function call. So F2 calls F3. What will be the value of I plus 1 in this case now? 3. So let's check. Is new string dot length not equals to 0? Please confirm. Is new string dot length not equals to 0? Please confirm. It's true. So what do you print? BC. And finally, what happens? Is index equals to str dot length? Is index, that is 3, equals to str dot length? Yes, true. So you return, and where do you go back to? F2. And at F2, what happens? New str dot pop. What will you pop? See, so back to this situation, and then I plus plus. I plus plus means I will become 3. Is 3 lesser than 3? Is 3 lesser than 3? No. So what happens? This is done, and you return back to F1. At F1, what happens? New str dot pop. What is the value that you will pop out? B. That means you are back to this particular situation. And then what happens? I plus plus, I becomes 2. Is 2 lesser than 3? Is 2 lesser than 3? Yes. So what do? New str dot push str of I. What is str of I? What is str of I? C. So you push C. And then what is the next line? What is the next line? A function call. What is this function call? What is this function call? F2 and I plus 1. What will be I plus 1? 3. And then you check. Is new string dot length not equals to 0? Is that correct? That is true. So what will you print? C. Is index equals to str dot length? Is that true? Yes. So F2 is done, and it returns back to F1. And at F1, what's going to happen? New str dot pop. What is new str dot pop? This is also done. And finally, you go back, and what happens? I plus plus. I becomes 3. What is 3? Is 3 lesser than 3? Is 3 lesser than 3? No, definitely not. That means F1 is also done. And can you look at your new string? Can you look at your new string? Is it empty again now? It was initially empty. Now it is empty again. That means where we are? We are back at the top of this beautiful little tree. And can you check the output? Are you getting all the subsequences? Are you getting all the subsequences? How many of you got this? How many of you got how this beautiful little code was working? If someone is not able to visualize it as a tree, this is for them. Got it? How this was done by this and the output was this, while in code is this. How many of you understood? Quite a lot to absorb, right? Quite a lot to absorb. No, no, yes or no, people? Once more, once more, you guys will do. That's why I didn't take A, B, C, D. Otherwise, it would have taken even longer. That's actually the biggest problem here. That you have to do so much. Any alternative? Of course not, man. You have to go through all the routes, no? You have to go through all the options, right? Correct? Yes or no? Okay. So it takes some time. But now one thing that should be very interesting for everyone to understand is what is the time complexity, right? Is anyone able to think about what will be the time complexity of this? Now there are three ways to come up with it. Basically, there are three methods to come up with the time complexity of a recursive function. Okay. One is master method. Now this is applicable for very limited scenarios. That's why we generally avoid it. It is just valid for very limited scenarios, hence we avoid it. Another one is the recursion tree method. Now this is something that we'll come back to when we'll be learning merge sort. Okay. For now, let's try to figure out the last method which is there. That is the substitution method. Substitution method. Okay. Arpit, that will take some time, man. That will take some time and practice. Okay. So Arpit is asking the question how to visualize the entire tree when you're going for it. That will take some time. Okay. But guys, we just focus on this part because this is also very interesting. Guys, sometime back, remember we spoke about, can you write the Fibonacci code in an iterative fashion? I told you that any code which can be written iteratively can be written recursively as well. Any code which can be written iteratively can be written recursively as well. Do you remember? We spoke about this. Can anybody write the code of Fibonacci in an iterative fashion? Can you write a function, a non-recursive code to get the Fibonacci one? Come on, go for it. You have 2 minutes. Go for it. Come on, everyone. Come on, guys. Come on. Okay, come on. Let's try to solve this. 2 minutes up, time to solve it. Now, the way I see it is I'll take the base case is still required that if n is equals to 0 or n is equals to 1, you don't have to do any computations, just return n, correct? Otherwise, what you can do is take a variable, let's say f equals to 0, take another variable, let's say s is equals to 1, and take a variable, let's say sum initialized to 0. And for I is equals to 2, I lesser than equals to n, I plus plus. What will I do is sum is equals to f plus s. And after this, f becomes equals to s and s becomes equals to sum. And finally, print sum. Will this work? Will this work, people? Of course, it will work. Let's try to find for smaller value. Let's say fib of 3. What is fib of 3? What is fib of 3? This is the 0th value, the first value, the second value, the third value. What is fib of 3? 2. Let's see if it is giving us 2. Okay. So initial value of f is 0. Initial value of s is 1. Initial value of sum is 0. The loop starts from I equals to 2. Is 2 lesser than equals to n in this case, which is 3? Yes. So sum is equals to f plus s. F plus s means 1 plus 0, which is 1. Then f becomes equals to s. That means f becomes 1 and s becomes equals to sum. That means s becomes equals to 1. And finally, I plus plus, I becomes 3. Is 3 lesser than equals to 3? Yes. So what do you do? Sum is equals to f plus s, which is f plus s, which is 2. And then f becomes equals to s, which is 1. And s becomes equals to sum, which is 2. And then I plus plus. Now 4 is definitely not lesser than equals to 3. That means it is done. And finally, what do we do? Print sum. What is the value of sum? 2. Is that the Fibonacci value, third Fibonacci value? Yes. So definitely this works. What is the time complexity of this nice little easy piece of code? What is the time complexity of this nice little easy piece of code? Just one iteration is there. So big O of n is the time complexity. What is the space complexity? Big O of 1. Correct. Big O of 1 is the space complexity. Nothing complex here. Everyone gets it? Everyone gets it? Everyone gets it? Okay, great. Now, if you get this, let's try to understand. Let's try to do the same code recursively. Okay, everyone understood the iterative code? Any doubts here? Okay, this is the iterative code, the time and space complexity both. Now, the same recursive code for this is fib of n if n is equals to 0 or n is equals to 1, I will say return n, correct? Otherwise, I will return fib of n minus 1 plus fib of n minus 2, correct? Correct, people? Okay. Now I want to find the time taken for this particular code. Can I just say the time taken for this particular code will be equal to the time taken for the same code, but for a different value, which is n minus 1. The same code, but for a different value, which is n minus 2. And some constant operation. This is some constant time taken, right? This won't change, right? Whatever the time taken is constant, right? So some constant operation, time, let's say c. Am I correct with this, people? Is this the overall time taken? Is this the overall time taken? The time taken to calculate the nth value is equals to the time taken to calculate the n minus 1th value, n minus 2th value, and some constant to check this, whatever it is. Okay. But now tell me one thing. The time taken to calculate the n minus 1th value. Now I'm talking about computers, right? Microseconds, milliseconds, microseconds. Can I just make an assumption that time taken to calculate the n minus 1th value is nearly equal to the time taken to calculate the n minus 2th value? Can I just make this assumption that there will be very small difference there? Now you might say in that case, the t of n bhi le lo. Nahi, t of n nahi le sakte. Why? Because it is twice of whatever the time taken to this is, right? We can't do that directly. But whatever is the time taken in this particular case, is nearly equals to the time taken for n minus 2. So for the sake of simplicity, can I write it like this? Time taken for the nth value is equals to the time taken for n minus 1th value, time taken for n minus 2th value plus c. Can I make this assumption? Can I make this assumption? Is it okay? Is it okay? I haven't made an assumption here. Huh? Nice. So basically, instead of n minus 2, I'm going to write n minus 1. Is it fine? Same, no? Almost nearly equals to the same. So this computation wise, this will become much easier. That t of n is equals to 2 into t of n minus 1 plus c. Okay. Can I say the time taken to calculate the nth value is equals to twice the time taken to calculate the n minus 1th value plus c? Am I correct? Am I correct? Why n minus 1 2 times? Adding this, no? Because adding this, here I said, no? That this is nearly equals to this. So this, okay? Okay. So the time taken to calculate the nth value is equals to twice the time taken to calculate the n minus 1th value plus some constant t. Okay. Now, this is a generic equation. Yes or no, people? This is a generic equation. In this equation, if instead of n, replace n with n minus 1, then I will get the time taken to calculate the n minus 1th value. Wherever it is n, instead of n, replace n minus 1. So here it is n. Instead of n, write n minus 1. This minus 1 plus c. So the time taken to calculate the n minus 1th value will be equals to 2 into t of n minus 2 plus c. Am I okay, or is it too much mathematics? This is not mathematics at all. Now don't count it for mathematics. I'm just taking values, replacing them somewhere. Ye kiya hai? 9th, 8th, 10th standard, 5th standard, 6th standard, 7th standard, somewhere. Have you done this? I'm just replacing values, nothing much. Okay. So I have the value of t of n minus 1. The value of t of n minus 1 is this, 2 into t of n minus 2 plus c. Can I put this value here? Can I put this value here? Of course I can. Why I can't? So put t of n equals to this. In that case, t of n is equals to 2. Now what is t of n minus 1? T of n minus 1 is this. 2 into t of n minus 2 plus c, and then this thing plus c. Am I correct? Am I correct? Isn't it? Is it confusing or is it okay? Is it confusing or is it okay? Okay, nice. Now t of n, let's multiply the brackets. 2 into 2 is 2 square into t of n minus 2 plus 2 into c plus c. 2c plus c. That means t of n is equals to 2 square into t of n minus 2 plus 3c. Is it okay? Can I write it like this? Can I write it like this? But I should know the value of this also, right? T of n minus 2. What is the value of t of n minus 2? Going by this equation, instead of replace n with n minus 2. So what will you get? T of n minus 2 is equal to 2 into t of, यहाँ पे instead of n put n minus 2. So n minus 2 minus 1, can I write it? N minus 3 plus c. Can I write it directly? Can I write it directly? It is okay. I just replace n with n minus 2. So I have the value of t of n minus 2 as well. Let me just replace this value here. T of n is equal to 2 square. What is the value of t of n minus 2? Look at it. 2 into t of n minus 3 plus c. 2 into t of n minus 3 plus c and plus 3c, which is 2 square into 2. What is 2 square into 2? Can I say 2 cube into t of n minus 3 plus 2 square into c, which is 4c, plus 3c, that is 7c. Can I write it like this? Can I write it like this? How many of you are able to observe some pattern? कोई pattern समझ में आ रहा है? Is there any pattern here? If not, try to observe this. 2 raised to the power k into t of n minus k plus 2 raised to the power k minus 1 into c. Now instead of k, put 1, put 2, put 3. You will get all these different equations. Isn't this a generic equation? How many of you are able to get this? How many of you are able to get this? How many of you are able to get this? It's a generic equation, right? Whatever we discussed. See? Okay. But now, This is the recursive time this is the time taken for this recursive piece of code. But we want to find out the time complexity. For time complexity, we have one advantage here. What is that advantage? We know the time taken for base case. We know the time taken to calculate the time complex and calculate base case. Time taken for the 0th value is constant, some unit value 1, some constant, right? We know that t of 0 is equals to 1 and t of 1 is equals to 1, correct? Yes or no, people? It's the base case, no? So why will it take time? It will take some constant time, yes or no? We know that t of 0 is equals to 1. Yes or no? Base case. Base case. Base case. Okay, guys, I know it's a bit complicated at this point of time, but trust me, it's not. It's just simple, very simple. Just using this, using that, using this, using that. That's it. Now, I know that t of 0 is equals to 1. So if there was a way I could make n minus k equals to 0, I could replace this thing completely. How can I make n minus k equals to 0? What should be the value of k such that n minus k becomes 0? What should be the value of k such that n minus k becomes 0? Okay, simple. So put k is equals to n in this equation. This equation is t of n is equal to 2 raised to the power k into t of n minus k plus 2 raised to the power k minus 1 into c. Put k is equals to n. So t of n is equal to 2 raised to the power n into t of n minus k. N minus n is 0. So can I directly write it as 1? Because t of 0 is 1. T of 0 is equals to 1. Okay. Plus 2 raised to the power n minus 1 into c. Okay. Everyone okay with this statement? Everyone okay with this statement? Now t of n is equal to 2 raised to the power n plus 2 raised to the power n into c minus c, just multiplying it, just opening up that bracket. And now taking out 2 raised to the power n common. 2 raised to the power n, 1 plus c minus c. This is the time taken. Correct? This is the time taken. Now tell me, according to the rules, to get the time complexity from here, what will you get? What do you need to do? Avoid constants. Avoid constant. Avoid non-dominating term. This is constant. Avoid. This is constant. Avoid. Whatever is remaining is the time complexity. Yes or no? What is the remaining thing? Big O of 2 raised to the power n. That's the time complexity of this particular code. That's the time complexity of this particular code. You remember the number of ways problem? You remember the number of ways problem? For every option, for every step, how many options did you had? Let's say if you have to travel 4 steps, for every step, how many options did you had? 3, 3, 3, 3. So what is the total time complexity? 3 into 3 into 3 into 3. If I have to travel n steps, for every step, how many options I had? 3 raised to the power n. Yes or no? In case of follow the night, for every step, how many options did I had? For the first step, I had 8 options. For the next step, I had 8 options. So let's say if I have to travel n steps, for every step, how many options do I have? 8 raised to the power n. So that's the time complexity. What is the time complexity of recursive codes then? Exponential. Exponential. Now, Rahul asked a beautiful question. Then how it is better than brute force? Of course, it is not better than brute force. That's why I'm going to write the most important line here. Recursion should be done only when absolutely necessary. Your first hint, your first solution, your first hunch should always be iteration. It should be done only when absolutely necessary. Like in case of for loop, in case of follow the night, it was absolutely necessary. That's why we went for it. And now I want you to do another small exercise. Whatever questions you have solved, just go and check the constraints out of it. Just go and check the constraints. The constraints would be extremely small. Why? The constraints would be extremely small. Why? Because the expected time complexity was exponential. Correct? Exponential. It might not be true in all cases, but it is definitely true in some cases. Correct? So that's the time complexity. That's why, should recursion be done in any case? Should recursion be done in any case? No, of course not. It should be done only when absolutely necessary, right? Similarly, let's say in case of the just question that we solved, generate all subsequences. Generate all subsequences, the question that we just solved. A, B, C. For every character, how many options did you have? 2, then 2, then 2. So if there are n options, 2 into 2 into 2, what is the time complexity? Again, exponential. Again, exponential. And that's why if you go and check the constraints out, what does it come out? Just go and check the constraints. Getting it? The constraints would always be very small. Is time complexity depending on the base condition? Yes, to calculate, definitely. See, guys, time complexity has nothing to do with the base case because it generally deals with the worst case. But to calculate it, definitely, definitely it's a thing. Okay, to calculate, definitely it's a thing. Now, someone is saying, I'm getting TLE in Fibonacci. You will get TLE in Fibonacci. You will get TLE in Fibonacci. Let me give you one hint for that. Okay, let me give you one hint for that with the help of Fibonacci. Let's say if I'm calculating fib of 4, for this, I have to calculate fib of 3 first. And for fib of 3, I have to calculate fib of 2 first. And for fib of 2, I have to calculate fib of 1, which is already counted, base case. And then I have to calculate fib of 0. And then again, I have to calculate fib of 1, already counted, base case, I return. But again, I have to calculate fib of 2, then fib of 1, and then fib of 0. Correct? This is how it works, right? This is how it works. Yes or no? Yes or no, people? This is the recursion tree for Fibonacci, correct? If I have to find the 4th Fibonacci value, I have to get the 3rd. Then for 3rd, I have to get 2nd, 2nd for 1, 1 kill is 0, and so on. Now, just look at this part. Just focus on this part. Isn't this part and this part same? Isn't this part and this part same? Yes or no? So if there was a way I could avoid solving this part again, because right now what's happening? I solved it once, I'm solving it again, right? If I could just store the answer, ki, fib of 2, no, I already counted it. Uska answer, yeah, don't count it again. Correct? If I just did this, it would save me some time, right? It would save me some computation time, correct? Yes or no? Yes or no? It would save me some computation time. Yes or no, people? That's exactly what people call as, कुछ smart लोगों ने उसको क्या बोलना शुरू किया? Dynamic programming, or in short, DP. So that's the same thing that you have to do in Fibonacci. I have given it intentionally where you guys can try this out. That's an optional question, but you guys should definitely give it a shot. Okay, fib of 2 is always 1. Of course, it will always be 1. It's the same case. In Fibonacci, what you have to do? For fib of 4, you just have to find 3. Fib of 3, fib of 2, and fib of 1. That's it. For fib of 3, you further have to find fib of 2, fib of 1, fib of 0. You've already calculated it here. Don't calculate it here. That's it. You solved it using iteration. Great. Not a problem. For validator, you have 2 weeks to solve it. Validator, I'll release a video probably next week ke baad. So you have 2 weeks to solve it. Okay, don't come to me at this early for that. Okay, you can solve object. You just have to figure out a way to store the answers. You can definitely use objects. You can use whatever you want, but you just need to figure out a way to calculate that. Does that make sense? You just need to figure out a way to store that. That's the only thing there. Got it? Yes, yes, of course you can submit without validator question. That's an optional one, guys. Don't worry. It says optional, no? It doesn't? I'll put it, not a problem. Okay. Cool, 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 guys. So I think that's it from my side today. More or less it. I hope everyone enjoyed the session. It was a slightly longer one.